Yes, hello, North High School. Just checking in. Just wanted to update you before we continue with the lesson on how I've been doing, because that's very important. As you can see, I got my Gucci glasses on. The fit, that's nice. I just want to let you know, since last week when I was shooting dice, I've actually doubled my money from $2 to another $2, which makes $4. Also, I got my AirPods. The case is kind of scuffed, but that's okay. And my LaCroix. Before we proceed with the lesson, I want to teach you a little bit of something about when soul was soul. So just listen up and enjoy. You might make fun of her, but I don't care. This is Etta James, Cadillac Records.
And I would rather be a blind girl, babe.
Feel the soul.
Than to see you walk away from me, baby. Ah, yeah. 'Cause you see, I love you so much. I don't wanna watch you leave me, babe. And another thing is, I just don't wanna be free, no, babe. Ah, no. Now listen.
Well, you might not have enjoyed it. I really do. And it's kind of symbolic of how I feel about you guys at North High School. Rather than see you walk away for the rest of the year, I'd rather go blind. Somewhat. I guess depending on the student you're talking about. So basically for today, there's two things. If you guys did not do any of the assignments from last week, please do them, especially the probability packet. I think I got back almost all of you guys' probability packet who handed them in last week with comments. Please read the comments. You do not have to respond to them. I'm just see where you made a mistake and see if you could do better next time. The grades were really good for the most part. Today, I just want to address some of the misconceptions that I saw in the packet. So, I created another kind of Google Doc. It's right here. It's 9 questions, but if you notice, half of the answers are in this lesson. So let's just run through it. Okay, here we go. So the first one is probability, because I noticed a couple mistakes on that. And the definition of probability is the number of target outcomes, so what you want to see, divided by the number of total outcomes. So here we have a spinner. How many outcomes we have? 1, 2, 3, 4. Sorry, the red didn't show up. So there's 4 total outcomes, always, every time. What's the probability of landing in blue? Well, there's only one blue section, so it's going to be 1 out of 4. So that you can literally type into your Google Doc. The probability of landing in red. Well, how many sections are there? There's just one red section, so it should be the same, right? What's the probability of landing on any chosen color? Well, what's the probability of landing on green? Is it the same as landing on blue? The same as landing on red? The same as landing on yellow? Yes, I'd say so, because since they're split up equally, there's an equal chance of landing on each color. I'm not going to write that down, but pretty much just gave you the answers. Now, so if we spin a spinner 20 times, right? 20 times, we'll write that down. In theory, right? Maybe not in practice, but in theory, how many times should it land on blue, red, green, or yellow? So we know that the probabilities of landing on each color are equal. They're 1 out of 4. Now, if we spin it 20 times, we just divide 20 by 4. Each time it should end up, each color, it should land on each color 5 times. And one way to do that is, what's 1/4 of 20 times spun equals 5. So that means if we spin the spinner 20 times, 5 times it should land on blue, 5 on red, 5 on green, 5 on yellow. Basically, we're just cutting the whole 20 times divided by 4. Okay? And what we call this is, actually we call it theoretical probability. Okay? Because that's what should happen. Is that going to happen in practice every time? No, but we're going to test that out right now. So we're going to run another simulation. So you guys are going to click on this link right here, and it'll bring you to this page. I have directions right here. So the first direction is to click not leave it, but click on the second spinner. So we're going to click right here, and it's going to bring up our spinner with 4 colors. Our next direction is to click 10 for the number of spins. So we're going to click 10. And then we're going to, oh crap. Oh, it says click spin 4 times here. That will be later on for you guys. But I'm just going to click spin 2 times here to see 20 times. So here, we spun it 10 times. And each color. Okay, blue actually came up none, and the rest of the colors came up pretty similarly. All right, let's click it again. So remember, we say each color should come up 5 times, in theory, but let's look at practice. Oh, that's crazy. I mean, usually it doesn't end up like that, but here, every color came up 5 times, okay? So even if it was a little bit off, what we call this actually, and I'm skipping ahead, is experimental prob. Okay. Now, really, this time it landed the same amount of times, but sometimes the results are different in theory versus practice, because theory is theory, right? And a simulation, there's more randomness. Right? Just because Steph Curry is a 90% free throw shooter doesn't mean he's going to shoot 90% every time. All right, the last thing is you guys can, so you're going to do the same thing, but this time you're going to click spin 4 times to do 40 times, okay? And now, the last thing I wanted to cover was sample space. A lot of you guys just put numbers, but you need to actually list all the sample spaces, all the schools. So if I say sample space of Minneapolis public schools, I actually have to write them down. North, I can't just write 7. I have to write North, Edison, Washburn, Roosevelt, Patrick Henry, Southwest, 1, 2, 3, 4, 5, 6. South. Okay, so that's my sample space. I actually listed all the schools. So your goal is to list the sample space for all the deans at North. So please watch this video and answer the questions. I will give another packet, but I'm trying to give daily lessons that are a bit longer, and we'll see what happens. Okay, thanks. Bye.